Determine the limit as x approaches positive infinity and as x approaches negative infinity of the square root of x squared plus 8x plus 6 divided by x squared minus 3x minus 1. The highest power term in the numerator is the square root of x squared. In the denominator, it is x squared. The square root of x squared equals the absolute value of x. The absolute value of x equals positive or negative x, depending on whether x is positive or negative. One of the x's in the denominator can cancel with the x in the numerator, leaving a 1 in the numerator. And the result is positive or negative 1 over x. For the limit as x approaches positive infinity, x is positive, the absolute value of x will be positive x, the result will be positive 1 over x. As x approaches positive infinity, 1 over x will go to 0. For the limit as x approaches negative infinity, x is negative, the absolute value of x will be negative x, the result is negative 1 over x. As x approaches negative infinity, negative 1 over x will go to also 0. Now to show that this is the case, starting with the limit as x approaches positive infinity of the square root of x squared plus 8x plus 6 divided by x squared minus 3x minus 1. The first thing to do is plug a positive infinity in for each of the x's. Only the highest power term in the numerator and denominator matter here. In the numerator, positive infinity squared is positive infinity, square root of positive infinity is positive infinity. In the denominator, positive infinity squared will be positive infinity. The result is positive infinity over positive infinity. We have the infinity over infinity indeterminate form here. We will need to rework this. To rework this, we will divide both the numerator and the denominator by the highest power of x in the denominator. That will be x squared. So we will divide the entire square root in the numerator by x squared, and every term in the denominator by x squared. In the numerator, the square root can extend over the x squared, by writing it as x squared squared, because the square root of x squared squared will be x squared. In the denominator, x squared over x squared is a 1. In the second term, one of the x's will be able to cancel from the denominator with the x in the numerator, leaving a minus 3 over x. And then the third term has no x's to cancel, remain as a negative 1 over x squared. In the numerator, x squared squared, multiply the exponents, will be x to the fourth. Each term in the numerator can be put over x squared squared, which will be x to the fourth. Over, and the denominator is left as is. In the numerator, the first term can have 2 of the x's in its denominator, Cancel with the two x's in the numerator, leaving a 1 over x squared. The second term can have one of the x's in the denominator, cancel with the x in the numerator, leaving a positive 8 over x cubed. And the 6 over x to the fourth has no x's to cancel. It will remain a 6 over x to the fourth. Each term that is a constant divided by x to a positive power will go to 0 as x approaches positive infinity. The result is the square root of 0 plus 0 plus 0 divided by 1 minus 0 minus 0. 0 plus 0 plus 0 is 0. 1 minus 0 minus 0 is a 1. Square root of 0 is 0, and 0 divided by 1 equals 0. Now to work out the limit as x approaches negative infinity. The square root of x squared plus 8x plus 6 divided by x squared minus 3x minus 1. The first thing to do is plug negative infinity in for each of the x's. Only the highest power term in the numerator and denominator will matter here. In the numerator, negative infinity squared is positive infinity. Square root of positive infinity is positive infinity. In the denominator, negative infinity squared is positive infinity. The result is positive infinity over positive infinity. We have the infinity over infinity indeterminate form here. We will need to rework this. And it is reworked by dividing both the numerator and the denominator by the highest power of x in the denominator, that is x squared. However, since x is approaching negative infinity, and one of the highest power terms that's in the numerator here is under a root, instead of dividing by a x squared, we will divide by a negative x quantity squared. The negative x quantity squared, negative squared is positive, and negative x quantity squared will equal the same thing as positive x squared, so we can divide by positive x squared. So we can divide the entire root in the numerator by positive x squared, and each term in the denominator by positive x squared. In the numerator, the root can extend over the x squared, by writing it as x squared squared, because the square root of x squared squared will be x squared. In the denominator, x squared over x squared can cancel to be a 1. And the second term, when the x is in the denominator, can cancel with the x in the numerator, leaving a minus 3 over x. The third term has no x's that can cancel. It will remain as a negative 1 over x squared. In the numerator, each term can be written over x squared squared. X squared squared, 2 times 2 is 4, will be x to the fourth. Each term can be written over x to the fourth. We'll leave the denominator as is. In the numerator, the first term can cancel 2 of the x's from the denominator with the 2 x's in the numerator, leaving a 1 over x squared. The second term can cancel 1 of the x's from the denominator with the x in the numerator, leaving a positive 8 over x cubed. The third term has no x's to cancel. It will remain as 6 over x to the fourth. And we'll leave the denominator as is. Each term that is a constant divided by x to a positive power will go to 0 as x approaches negative infinity. The result is the square root of 0 plus 0 plus 0 divided by 1 minus 0 minus 0. 0 plus 0 plus 0 is 0. 1 minus 0 is 1. Square root of 0 is 0 over 1, and 0 over any non-zero number equals 0. And there's the results of the two different limits.